So something I've been wanting to put together for a few semesters now is a bonus point opportunity for computer coding. Computer coding is becoming essential for more or less anyone wanting to go into the physical sciences. And as a result, we want to give you an introduction into how to build some basic code and how to utilize that code to either run some basic simulations, plot some data, or do some interesting calculations. For example, if you need to do an integration of a function that is not elementary or analytic. Um, as often happens in higher mathematics and higher physics and chemistry, um, you will often find functions where a antiderivative does not analytically exist, like we're used to with sine and cosine, where the integral of sine is negative cosine, or the integral of cosine is simply sine, and so forth. But if you have a really complex function and you need to integrate it over a volume or over a surface or over some interesting limit range, then numerical is how you're going to have to do it. And how do you do that? Computer science coding is also going to enable you to solve matrix problems very, very quickly and efficiently. And particularly in this course, when we get to Kirchhoff's rules, it will actually become quite beneficial to know how to do those linear algebra techniques. And so I want to create a short series of videos that will show you some of the basics that I've picked up, and a caveat here, okay? I am mostly self-taught on some of the things that I'm going to show you. I don't really have much formal training, but on the flip side, I am using code, and I'm using Python in particular in my research, and I am writing code as I need it. And I will share some of the basics with you that I have picked up, and then I'll also post a few short videos showing different techniques, as well as post short bonus point extra credit exercises that you can try throughout the semester. So, first things first, in the world of computer coding, there are several languages, and it depends on the kind of science that you're going into as to what might be standard in the field. In physics, right at this moment, Python is becoming the ubiquitous language that most physicists are using. Now, there are other languages, and there are other languages that are more suited for other disciplines. For example, if you're going into engineering, you may use or may be familiar with already some MATLAB. Um, if you're going into data science, then you might be familiar with R or Java, or you may have been exposed to Python. A new up and coming language that is getting some attention, particularly among Python users, is Julia. Now, what we're not going to do with this short video series is talk about all of the intricacies and the differences between these languages and so on. I am taking the approach of riding a bicycle or driving a car, right? We don't need to know all of the intricacies of how a car works to get behind the wheel and drive and go somewhere. Right. Uh, it helps to know how a car works if you're ever broken down, or the computer coding equivalent of that would be when you're debugging your program. But if you just want to get behind the wheel and drive and you're not terribly concerned at this particular juncture with the intricacies and the jargon of computer coding, then this series should be helpful. If you are interested in those types of things, then I can point you toward some more sophisticated resources. First things first, how do I get Python? Okay, so the most popular distribution for computer science data or scientific analysis is known as Anaconda. And as we'll see in just a moment, this particular distribution of Python contains um, all of the scientific packages, or at least most of the science. It contains all of the scientific packages that we will use, and it contains many of the scientific packages that you would use in upper level coding, especially if you were doing something like machine learning, where you're trying to train a computer program to recognize sophisticated patterns. Um, it doesn't have every single package out there, but you can easily add them. But in any case, this is probably the most robust out of the box package that you can get without having to update anything yourself. And if you're new to the world of computer coding, then you don't really want to go in and fiddle with updating packages and adding packages and things like that as it can get pretty hairy pretty quickly. So my personal recommendation would be to go to simply this website, anaconda.com, products individual. Now I'm using a Linux system for this presentation, but it has Windows and as you can see, it has Windows and Mac installation packages as well. If you just click download, then you'll be able to access what is called a interactive development environment, or IDE. Now in Linux, the way that I um, access that is I bring up a terminal, and in fact, let me do something real quick here. Okay, so I don't know if this is going to work the way I want it to, and I don't think it is. So let me get rid of that. Okay, so let me see if this works. Oh, wait, just a moment. Oh, that didn't do it. In any case, um, we won't worry about that for the moment. But what I would actually recommend is not using this package for the moment. Okay, this is if you are seriously wanting to get into coding, maybe after the first few exercises and you realize there are things that would be useful for you to do. But otherwise, what I would recommend is actually using this website. Um, and let me increase the um, range here. So pythonbaba.com, and you can navigate through the website to this particular screen, online Python compiler, or you can type this directly into your address bar. But this brings up a Python compiler. Okay, so this has more or less all of the packages, at least that we would use for if you were to download Anaconda. Okay, so without further ado, okay, when you bring this up, okay, this is the first thing that comes up. So it already has a program pre-programmed in here. And the run button is this play button right here. And this is where your output is going to be. So if I hit that, you'll see that the computer prints hello world. Okay, and this is a pretty standard first program for computer science use. Um, Now, why this particular website when there are other Python compilers and interpreters online that you can use for free? And by the way, this is free. The reason is because this particular website has built into it the main packages that are used for computation. Okay, a lot of people use computer coding for many different applications, and if you're building an app for various reasons, you may not need, very intricate statistical packages. You may not need trigonometric functions and all of those kinds of things. You may just want to sort a list of web search results, right? If you're shoe shopping and you want to sort a list of results by price, for example, you don't necessarily need the higher level math functions. But this particular website is built for science and engineering. And so the first package that I'm going to discuss is this package, and I'm going to import it into the terminal in a very specific way. Okay, so import. Now, the package itself is called Numpy, and this stands for numerical Python, all right? And what we're going to do is what this command does, okay? What this command does, imagine, okay, Numpy is what's known as a library, okay? So it is a library of mathematical functions. Okay, so Python by itself can do basic arithmetic, but it can't do high-level math like interpreting trig functions and so forth. So if you want to use trigonometric functions, exponential functions, logarithmic functions, and so forth, you need to access those functions, and that is done by importing NumPy. So this would be the same thing as going to a library and checking out a trigonometric book as a reference. Okay. The next thing, and the reason we import the library into our program this way, import NumPy as NP. This allows for the computer to debug very easily, or actually it doesn't allow the computer to debug very easily. It's actually for your benefit. Okay, so when you're debugging code, the functions that NumPy has, the trig functions, logarithmic functions, and so on, other packages also have those built in. But sometimes they get implemented in slightly different ways, which will lead to slightly different calculation results. So if you have to use multiple packages and you're not sure which package is using the sine function, for example, it can be difficult to debug your code if you're trying to track down an error. So the way that this is imported will actually help you know under which package you are using a specific function. And we'll see how this is imported or utilized here in just a moment. So what I want to do in this particular short program is I want to show you how to build a basic plot, okay? How to display a plot of some data, how to generate some data, all right? So the NumPy is going to house our trigonometric functions, logarithmic functions, etc., etc. And so to actually import the graphical package, this is actually what we're going to use to display the graph. The graphical package in Python is known as matplotlib or mathplots library. Okay, so we're going to import matplotlib. This is the library graphics library, if you will, for Python. And pyplot is a subpackage within matplotlib that will allow us to actually display the graphics. So matplotlib will build the graphics, and then pyplot is the subpackage that actually displays the plot. Okay, it builds the plots and displays the plots. And we're going to import this as PLT. Now, you can actually name these, import numpy as and import matplotlib.pyplot as, whatever you wish. You can put whatever you wish right here or right here. It doesn't matter. But this is the standard within the field. These are the things that have become standard within the field. All right. And so with that in mind, we're actually going to build a basic plot. So let's do that. So what we're going to do, now, if you've ever plotted data in Excel, all right, what I'm basically going to do here, okay, what I'm going to do, I'm going to, first things first, define a variable, okay? So, for example, everybody in here has taken 231. And so that means that you should be familiar with plotting position versus time data, right? So, for example, let's suppose that I have some position data and some time data. And so I'm going to create some times. And what I'm going to do with this, this is equivalent to making a column in Excel of different times, and they're all going to be equally spaced. And so the command to do this, in our case, is going to be np.linspace. Now, what this command is going to do is it's telling Numpy that I want to create a column or a set of numbers, and I want these numbers to have some specifications, and that's what we're going to do right now. And for kicks and giggles, let's just let our stopwatch run from 0 to 10. And I want my total number of times to contain 10 data points. Actually, let's do 11 data points, so we actually have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you use the linspace function, from the NumPy package, then what it's going to do is it's going to say, okay, the first point is where I'm going to start my list of numbers. The second is going to be where I stop the list of numbers, and the third number is the total number of elements that I'm going to build. So if I type in 11 right here, what I'm going to do is I'm going to bind this list of numbers. Actually, it's technically an array, but for the moment you can think of it just as a column of numbers that you would use in Excel. And my first time is going to be 0, and then 1, and then 2, and then 3, and then 4, and then 5, and then 6, and so on. And if I hit enter, all right, this means that that command is now going to be run if I hit this particular button. Now, nothing should happen, nothing interesting should happen when I hit the run button here, okay? But this is good because this means that the checker, the internal checker, hasn't found an error and I haven't committed any syntax flaws. And so therefore, so far so good. My program is doing things right. And if I want to make sure that my times are the way I think they ought to be, 0, 1, 2, 3, so on, I can tell the program to print times. And if I do that, I should see the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for a total of 11 elements in this, what is technically known as an array. For example, just to see what would happen if you accidentally forget that 0 is included in your measurements and you say, okay, I want to go from 0 to 10 and I want there to be 10 numbers, and I do the same thing, now it's going to evenly divide 0 to 10 into 10 elements. Okay, so to do that, because there are 11 elements 11 numbers, 11 integers divided by 10, this is the same thing as 11 divided by 10. And 11 divided by 10 would be increments of 1.11111, and so on. So that's why you get these fractional numbers or repeating decimal numbers here. Okay, so it pays to pay attention to or remember what your intervals ought to be if you know what they should be ahead of time. So this just basically is the equivalent of a column in Excel of some times from 0 to 10, right? At integer markings. So imagine you stopped your stopwatch at exact integers. And suppose we were tracking the position of a falling object, and we know what positions of a falling object do. If I drop an object from rest, it follows a path according to 1/2 gt squared, right, where t is times. So if I assume that my path is following that same thing, then my positions should follow 1/2, and star is your multiply sign, g is 9.8. I'll show you something else that I can do here with this. And the way to do exponents in Numpy is not with the caret. Okay, if I do this, I'm going to get an error. Okay, so anytime you see something like this, Python doesn't know what to do. It doesn't like this. So the exponents in Python are actually double asterisks. Okay, so you have the double asterisk, and now it should run, right? Now, what do I want to do with this? Okay, well, if I want to plot this, then and by the way, okay, let's before we go on into the plotting, let's talk about what's happening here. So this positions, what this is doing is it's taking each element in the times, okay, it's taking each element in the times and plugging it into this equation. So it's taking 0 and plugging it into this equation. And then it's taking 1 and plugging it into this equation. 2, plugging it into this equation. 3, plugging it into this equation. And so on for the entire range of the time array. All right, so this is automatically going to be an array as well. And I can see what it looks like. No, that was right. Okay, so I can see what that looks like. Ooh. That's because I misspelled positions here. So let's try this again. Okay, so my first position, if my object follows that rule, is going to be 0 because 0 squared is 0. So this whole thing is 0. At 1, 9.8 times 1 times 0.5 is 4.9. 2 squared is 4. 4 cut in half is 2. 2 times 9.8 is 19.6. So it's doing the calculations appropriately, right? It's doing the calculations appropriately. But the ultimate goal of this short tutorial is to actually show how to make a plot. So what we want to do now is we want to say PLT. And so because linspace is a function in the NumPy library, because we imported NumPy as NP, we put the NP dot here. And again, this is where the debugging comes in. When you have functions from different libraries that can be used the same way, like sine or cosine or logarithmic functions and things, if there's an issue to debug, this lets you know, okay, I drew this from the NumPy library. So now I can go into the NumPy documentation and see how that particular function is implemented and see if that's the problem in my code, right? So this PLT is serving the same purpose as the NP dot here. This is purely for notation, okay? But if you import your libraries in this fashion, then you have to have the NP dot here and the PLT dot here, or else things will not work properly. So to plot functions in Python, or to plot arrays, if I want to plot one array against each other, all I have to do is specify which arrays I want. So what this is going to do, by default, it's going to put your first array on the x-axis, and it's going to put your second array on the y-axis. So we should see a typical parabola here. Now, one thing that's going to happen is when you don't specify any other way to do things, it's going to default to a blue line, okay? So Excel likes to default to the same, and Python will do the same thing. And to actually get the plot to show, I have to tell the program to actually display it. And this is the command here. So this first PLT line is saying, okay, I'm going to draw from the matplotlib.pyplot library, which is where my actual plotting is taking place. So I'm asking that particular package to then plot my times and positions. And then I'm asking that same package to actually display my plot. So let's see what this does. Whoop. That's because I need the command to actually plot it. Duh. Okay, so you need plt.plot. I forgot that. So here we go. And here's a plot of our parabola. Okay. Now I haven't labeled my axes. We'll show you how to do that in a later video. But this gives you the ability to create plots with sets of data. If you know how to generate your data, this is how you can plot it. And this is the anatomy of a lot of the types of programs that I will walk you through. All right. I'll make just a few notes about a few things. Number one, you may want your graph in this format. You may not want it. If you want to see your individual points, okay, the way to do it is Python has a library of colors and marker types that will allow you to customize your plots in a lot of different ways. Some of the basics are, if you want a blue line, that is specified by lowercase b. If you want a black line, that is specified by k. If you want a red line, by r, and so on. Green, I believe, is G. I think it's G. And your marker types, if you want a solid line like we have, that would be a dash. If you want a dashed line, that is 2 dashes. And if you want a solid point, that is an O. Now, these aren't the only marker types, but these are some of the more common. So, for example, if I wanted a blue double dashed line, I would type this, and this would result. So here we have 2 dashes, or not 2 dashes, but just a dashed line that represents my curve. More often than not, when we have physical data, what we're going to be interested in is seeing the individual data points. So if I want blue circles, then this is what I would plot. And sure enough, those are where my data points are. Um, and if I wanted a set of black dots, right, then, whoops, not B, I need K. If I want black dots, we have this, and so on. All right. Now, if I want a circles with dashes through them, then I can do this, and so on. So there are lots of different ways that you can customize your markers and customize the way your plots look. You can add legends to plots so that if you have multiple sets of data on the same plot, you can keep track of what's what. We won't get into that here, but this is just the basics of importing libraries into your program and building arrays that you can actually do calculations and plot with. Okay, so those are the goals for this particular lesson. Upcoming, we will talk about some of the actual functions that are in Numpy that you can use. And then we will actually build some sophisticated techniques. One of the things that we will definitely do is we will look at how the linear regression works. I do want to show you guys how the linear regression works. Okay, some of the math behind when you go into Excel and you fit it with a straight line. What is Excel actually doing, and how you can actually go beyond Excel if you need to. There are definitely times that you'll need to go beyond the sophistication of Excel. But this gets you started, and if you have any questions, feel free to let me know. But I hope you guys find this tutorial helpful, and look for some short extra credit assignments forthcoming. All right, we will see you guys next time.